Hi, I received a lot of questions regarding the differences between linear and circular motion. And we all kind of know intuitively that linear motion isn't exactly the same as circular motion. An example, in one-dimensional motion, you have x going in this direction, whereas in circular motion, you're dealing with a circle like this. So how do we tell the difference in certain kinds of problems when dealing with these? And that's what I wanted to address in this video. First, I wanted to mention these equations. Kinematic equations that you've seen before are the x direction ones right here. And you'll notice that all of these have equivalents in rotational motion. But why do we use two different symbols for them? And it's because they're not describing the same thing. You have these for linear motion, dealing with a delta x displacement in one-dimensional motion, whereas you have these equations that deal with circular motion. So delta theta is describing the displacement at a certain angle theta here, whereas delta x is from where you start up to where you end up in either a straight line or projectile motion when you break it into components. And with velocities, you're dealing with how these two displacements change. So your angular velocity, we typically depict it as moving either in a counterclockwise or a clockwise direction. But the actual direction that it's pointing is out of the plane of the page. So typically you'll see it like this with just a dot. So that's why we denote it clockwise, counterclockwise, when really you'll get something looking like this. And so your omega will either point out of the page or into the plane of the page. So that's important to keep in mind. Another thing I wanted to address is why we have three different types of acceleration we deal with. And it's because we're dealing with how things change in circular motion. And so we have three types. We have a centripetal acceleration in linear motion. We have alpha, which we denote as the angular acceleration. And then we also have a tangential acceleration, and they're all vectors. So what are the differences between them? And it's all based on how the displacement changes that affects the velocity, and thus how the velocity changes to have different types of acceleration. So centripetal acceleration is just a constant magnitude force, or constant magnitude acceleration due to a certain force in circular motion. And it just points towards the center of the circle, keeping it from moving in a straight line from its tangential velocity. Your angular acceleration, alpha, deals with how your angular velocity is changing. So this value right here. So that's why with alpha, we denote it as also being out of the plane of the page or into the plane of the page, because it's based on how this omega is changing. With your tangential acceleration, it deals with being in tangent at this point and how your linear or tangential velocity is changing. So you'll see this velocity here that's tangent to the plane, which is the direction it would go if it suddenly broke off at this point. And so your tangential acceleration is dealing with whether this velocity is slowing up, slowing down, or speeding up. And so if it was speeding up, it would be pointing in this direction. And if it would be slowing down, it would be pointing in this direction. So it's important to keep this in mind when dealing with the different types of motion. One other thing I wanted to address is the differences between units in certain motions. So if it's not clear whether something is circular motion or linear motion, check your units, because your tangential acceleration, so here, or your centripetal acceleration will always be in meters per second squared. Those are the SI units. However, alpha is always depicted in radians per second squared. And your frequency is going to always be in hertz. So 1 over s, or in revolutions per minute. And your omega, your angular velocity, is always going to be in radians per second, which is often confusing because if you're given revolutions per minute in a problem, most of the time you'll plug it in as your angular velocity, and that's not the case. To convert it to angular velocity, we have an equation where it's omega is equal to 2 pi times your frequency. So using omega equals 2 pi times the frequency, you can easily convert between your frequency, which are always in these units, to your angular velocity, which are in these units. And I know it's often confusing when dealing with this topic, so just keep these in mind and you'll do well in this part of the course.